now we'll be able to join in, and we welcome everyone who is online. For those who have not been online, my name is Ronald Dungu, Principal Education Officer at the Ministry of Education and Sports. And with the luck, this afternoon I had a workshop here at YY Court with the head teachers of Chitigum district, and that is why I got a chance to meet the beautiful ladies here. I want to thank all the teachers for the good work they are doing, bringing you online, and the head teachers for enabling you to join. I want to thank all the teachers who have been working with us since we started on this program, and this is the second week and last week before your mocks. We want to wish you the very best as candidates. Remember, we are in the new curriculum, and your performance is our wish as a Ministry of Education and Sports. The Ministry of Education and Sports has provided a projector and a screen to 1,400 schools and a laptop to help us connect to everyone. And I'm sure in the near future, we shall have more of these equipment provided to schools if we show the reason why we need them. So I want to welcome our presenter, our physics teacher, who will be introducing himself to us this afternoon, and wish everybody a good evening. We shall be here as YYO Court joining in. I myself, I'm going back to the workshop, but I will continue in the, I will join back as soon as I can. Thank you for listening, and thank you, everyone. I would like to declare this session open. Over to you, Mr. Kaziba. Thank you.
Thank you so much, Principal Education Officer, for those remarks. And thank you so much for connecting YY Okot Memorial College to this session. We want to thank all the teachers, and we want to welcome all the schools that have joined in. I'm going to start sharing my screen, and you'll confirm that my screen is on. Okay. Yes. Let me hope everyone can see my screen. I have shared my screen. Let me hope it is very clear to you and to everyone watching. In our session today, we are going to focus on physics paper, and we are going to focus on paper 2. And for schools that have big numbers, you do both paper 2 and paper 3. That is where we are going to focus our session today. In our physics practical has 3 major areas. Has mechanics, where you look at things like acceleration due to gravity, where you look at Hooke's law. That is now the part. Then we have optics, and under optics, that's where you look at things such as concave mirrors. That's where you look at lenses. Then you have electricity. That's where you look at things like resistance, EMF. Now that is under electricity. Now when they are setting this particular paper, you can find that in your paper, you have an item from mechanics, or it can be from optics. But the same paper, you can find that they can set either mechanics or electricity, or they can have an option of having electricity and optics, meaning that when you are reading, you need to know everything concerning the physics practicals. So an item can come from any of those 2 sections, and our paper will always have 2 items, but from different elements of construct. Now, we have some common apparatus that you need to know in mechanics. Now, under mechanics, these are some of the common apparatus that you need to know. Now, where we are, you need to know the apparatus name, that this one is called a spring balance. that this one is called a meter rule. This one is called a stop clock. So you need to know the name of that instrument and what that instrument is used for. Is it used for measuring diameter? Is it used for measuring length? What is it used for? And then after you knowing the name, you need to know how to use that particular instrument, because we are testing. Does the learner know how to use the instrument? And can the learner go on to accurately measure any physical quantity using that particular instrument? Now, for mechanics, there are some common, or what we call, experiments that, dear students, I want you to know that if an experiment is coming in mechanics, what experiments should you have at your fingertips, or what things do you need to know? Now, one of them is what we call determination of the force constant of a spring. They can bring for you a scenario that is about force constant. And now under this is where you need now also to go on and know that when they talk about Hooke's law, which kind of relation do I need to know? That do I know that force is going to equal to K times E, whereby E is my extension, K is the spring constant, and F is the force. Then from here, you need also to go on and now know that when I have force, force can be given by mg equals to K times E. Now, under this, you go on and say now, when I am in the laboratory, what things can they have in the laboratory? That means that here, you are going to look at mass. Mass can change, and the extension of the spring can change. Now, you need to have that at the back of your mind. So that is one of the experiments that I want you to know at your fingertips. Another experiment can be determining the center of gravity of a meter rule. That one you need to know. Now, determining the center of gravity of meter rule, then there you need to have at the back of your mind what we call the principle of moments. When you are determining the mass of the meter rule, still you need to know that that is application of the principle of moments. They can give you a wooden block, they can give you any object, and they want you to determine the mass of that particular object. Now, whenever they ask you some of these things, those are some of the things you need to have at the back of your mind. Other experiments you need to know, it can be about determination of the density of the liquid. They can give you a liquid, it can be paraffin, it can be milk, it can be any liquid. And then they may ask you that determine the density of that particular liquid. But also it can be about determination of the relative density of a solid or of a liquid. Now, what does it mean? It means that when you are revising, when you are planning for your practical, it means that you need to know the experiments concerning that. Another experiment you need to know is the one for determination of the acceleration due to gravity. It can be either using a simple pendulum or it can be using a spring. One of those things can be used when you are determining. So let me give you some few minutes such that you can be able to take note of those quickly. So take a few minutes and then okay. So those experiments, have them at your fingertips. At least know if they talk about this experiment, do I know how to do it? And which kind of application do I need? That here I'll need the principle of moments. Take an example. In case you are dealing with, let me say, the mass of the meter rule. You want to determine the mass of the meter rule. That you want to determine the weight of something. What do you need to know? Now here you need to know that if I'm looking at the mass of the meter rule, what do I need to know? Then there you need to have at the back of your mind the principle of moments. that if this is my meter rule that I am balancing, and I have a known mass, let me say this is mass M, and maybe let me just assume, let me just extend this meter rule somewhere here, and maybe this is my center of gravity, whereby this is, let me say, my weight. Now you need to know that under this, I'm going to be using the principle of moments. So you need to have that at the back of your mind. So that is about the meter rule. So that one, please pay attention to it. So those are some of the experiments. In case it is about density of an object, then you need to know that density is given by mass out of volume. But here now you need to know that what kind of relation do I need? That when I cross multiply, I'll have density times volume is equal to mass. That means that if I'm looking at the density of something, I can look at mass, I can look at volume. But when you are looking at volume, then you need to know that I can look at area times the length, because volume is base area times the length. But you may find that the object you are dealing with has a uniform cross-section area. So you need now to know which kind of relation am I going to be using when I'm working on that. In case it is acceleration due to gravity, then you need to have at the back of your mind this kind of formula, whereby you need to have the time and you need to adjust the length, or depending on the mass. So those are some of the things you need to have as you approach experiments concerning mechanics. Okay, then we have optics. When we are dealing with optics, those are some of the common tools that you can use. When you look at one of my screens, I'm showing you some of those equipments that you must have in your laboratory. When you look at that screen, you can see I'm going to pin it. Let me pin it. Okay, so when you look at my screen, you can see that these are some of the common apparatus that you can have within the laboratory. You can have this is the bulb holder. You can have, when you look at my screen, I have here, this is the bulb, this is the cell holder, this is what we call our white screen. When you look at them, let me first stop sharing this such that people can see very well. When you look at my screen, okay. Okay. When you look at my screen, you can see the different things. That this is what we call the white screen. You can see that here I have my bulb. You can see that I have here the cell holder. This is the double cell holder. I have the meter rule here. You can see I have the wire goes here. You can see that still I have here. This is the mirror holder, or depending on what you have, this can be a lens holder, and this is your mirror. So these are some of the things you need to know when it comes to the physics experiment concerning optics. Okay, so under this, what are some of those must-know experiments? When you look at my screen, I have tried to put for you some of those equipments that you need to know. And what are some of those equipments? Those are the ones that I've been able to show you. But I want you also to pay attention that you can have, when you look at my screen, you can have, this is a glass block. A scenario can come when it's about a glass block. This is what we call a lens. This is also a lens, and these are mirrors. Okay, so those are some of the common equipment that we are going to look at in details. Now, what are some of those experiments you need to know? Now, when it comes to experiments concerning light, you need to know, how do you determine the focal length of a convex lens? How do you determine the focal length of a concave mirror? How do you determine the refractive index of a glass block? These are some of the experiments you must know. There are other experiments that we can have here. Let me say it can be about the power of a lens. It can as well be asked. But here now, there are those ones that are basic that you need to know as you approach. But here, as you approach light, I want you to be able to know what we call the mirror formula. You need to know this formula very well because it's going to help you as long as you are dealing with lenses and you are dealing with mirror. And do not forget that U is what we call the object distance. And then V is what we call the image distance. And F is your focal length. Then when it comes to the glass block, I want you always to have at the back of your mind that always refractive index of the glass is sine I out of sine of R, whereby I is the angle of incidence. When you have a glass block, you need to know that you have the angle of incidence and the angle of refraction. So this is your angle of incidence, and then you'll have the angle of refraction. Now you need to have that at the back of your mind as you approach any scenario concerning optics. Then we have experiments in electricity. Now, when you look at electricity, these are some of the common apparatus that you need to know. You need to know, how does an ammeter work? And how do you know that something is an ammeter the moment you see an A inside? How do you know that something is a voltmeter when you see something inside? Now, from there, you need to know, some of you have switch. This is a switch. Some of you have a switch like this in your lab. Some of you have a switch of this type. And now these ones are what you call the Constantine wires. Now, these are some of the common equipment that we add on the ones you have already seen when it comes to something concerning electricity. And what are some of those experiments under electricity? Now, when it comes to electricity, you need to know, how do I determine resistance of per meter of a wire? How can I determine the internal resistance of a cell? How can I determine EMF? What about resistivity? And what about resistance of a bulb filament? Those ones are very crucial. So what do you need to know? You need to know how connections are made, because that one is very important. Sometimes you make connections and you find yourself things are deflecting or are not working. Why? You need to know that whenever we are dealing with electricity, whenever you are dealing with electricity and you are going to use a voltmeter, it must always be connected in parallel. Now that one you need to know at the back of your mind. So those are some of the things that you need to put at the back of your mind. So that one is very important. These are some of the experiments. How do you determine internal resistance? How do you determine the EMF of a cell? And which kind of relation do you need to know? Now here, I want you always to know that voltage is I times R, where R is the resistance, I is current. But also you need to know that EMF is given by I into R plus small r, whereby this small r is your internal resistance. Now, as long as you are approaching electricity, have those formulas at the back of your mind. They are going to be very crucial when you are testing out or when you are approaching. Yes, so you need to have those things at the back of your mind. Okay. Okay, we are going to continue. Some people are saying they are not seeing my screen, but from my end, I think I'm seeing the screen. So maybe kindly confirm, but I can see my screen on. Okay, now we have what we call measuring instruments. In the laboratory, we have those instruments. We have instruments in the laboratory. And it is always very important to know to how many decimal points are you supposed to write? Because when we are scoring, we are always very keen. We are always very keen to how many decimal places have you written your dependent variable. To how many decimal points have you written your value? Dear students, the number of decimal places to which we write any given instrument depends on the least count of that particular instrument. Now, whenever you are going to be using a meter rule, please take note that a meter rule measures to 1 decimal point and it is 100 centimeters. So that one, any reading you get from a meter rule, we shall measure it in centimeter. Now, when you are writing your units, please take note that when you are writing your units, always make sure that they are on the same line. Let me say these are centimeters, I write centimeters. And please take note that these are small letters. In case I'm dealing with a stop clock, I'll write to those particular number of decimal points. In case it is a stopwatch, I write to 2 decimal points. And know that these are seconds, so you write your small s. When it comes to a measuring cylinder, we write to 0 dp. When it comes to a protractor, we write to 0 dp. When it comes to an ammeter and a voltmeter, here we write them to 2 decimal places, but it depends on which kind of voltmeter or ammeter you have within your school. Some of your schools have voltmeters that can write to 1 dp and ammeters. So please, you check out the list count. To get the list count of any given instrument, get the digit of that instrument, divide by how many small boxes or small spaces you have to reach another digit. And then once you divide, you'll get to know the list count. So this, however, I want you to take note that ammeter and voltmeter, since these were people, we write their units using capital letters. So whenever you find a capital letter as a unit, please take note that that one was someone's name. In science, if you discover something, if you do something of significance and your name is abbreviated after a scientific, a minute. So in science, whenever you do something that is very significant, many times they can use your name to call it as a what? An SI unit. So please take note that ammeter is a capital letter, voltmeter is also a capital letter. Then for grams, those are small letters. So when you're writing, please take note of that distinction between those two things. Okay. Why? Are you able to hear me? Maybe you can check out your microphone, but let me hope other schools are able to hear me very well. Yes, kindly let me know in the chat. Is it YY only, or other schools are also not getting me clear? Are other schools getting me clear? Okay. Okay, people are saying they are getting me clear. Okay. Okay. Then we are going to go to table of results. Dear students, this is where you need to score highly. When it comes to the table of results, one of the things you need to take note that your table should always be closed and we always write in a column 4. So we expect that you are going to draw for us a table and then you close it. Avoid drawing tables. However much time has caught you, avoid doing Y and then you say X and then you leave your table like that when it is not closed. This is not a closed table. You are going to lose out on the scores. Draw your table very well using a ruler and use a pen. Don't use a pencil. Now, where units apply, please have the units in brackets. Let me say you are writing your Y and your y is in centimeters, put the bracket and write in centimeters. Don't just write this. Don't write that. So make sure that whatever thing you are doing, you write y and then you put in brackets that those are my units. The table must be drawn using a pen. That's why sometimes even your teachers have told you, don't. Okay. Yes. So your units must be your units must be very, very okay. When it comes to units, please write them very, very well. Okay, I think I think I've seen a comment. I've seen a comment. Okay. Yes, the units are amperes and volts. Here, for ammeter, amperes. And when you are writing amperes, we shall always write ampere. And here, these are what? Are volts. Okay, thank you. I think the pronunciation didn't come out well, but thank you. Okay, so all values in the same column must have the same number of decimal places. So make sure that the number of decimal places that you are writing are the same throughout. Okay. Now, I want to use this as a sample table. When you look here, I have given you a sample table that we are going to do together. Now, as we are writing, I want you to take note of the following. Whenever we are multiplying two quantities, I am multiplying U and I'm multiplying V. We always consider significant figures. Whenever you are adding units, addition, subtraction, we consider decimal places. Whenever we are dividing, we consider still significant figures. What do you need to take note of? You need to take note of that when you are multiplying, we always first check out what is the largest product in your columns. We always check out what is the largest product. Product means that what are those figures which when you multiply give you the largest answer. That's what we call the product. Now, when you look at the pair, always I encourage that you can use your eyes to look at the pairs you have. Let me say this is the first pair up and this is the last pair down. Always you can first test the first pair up and the last pair down. What do you need to know? You'll come and ask yourself, I'm multiplying. Let me start from up. How many significant figure is this value having? So when you check here, this is 1, 2, 3. So this one has 3 significant figures. What about this? 1, 2, 3. Also, this has 3 significant figures. Meaning that the answer you are going to get, since 3 and 3 are the same digits, it means that the answer you are going to get will have 3 significant figures. So when you multiply 20 times 20, you are going to get your answer as 400. And 400 has 3 significant figures. Test the value down as well. When you look at my value down, has 3 significant figures. This value here also has 3 significant figures, meaning that the answer I write must have 3 significant figures. So you place your calculator. Once you place, you write 576. The next question you are going to ask yourself is, on this value I have here and this value I have here, what is the largest? What is the biggest? And you can note that this is the biggest value. So that is the first value you write in your column. So I'm going to come here and I write 576. Now, this value you have written is the one that dictates to how many decimal points you are going to write all your values within this column. So under this column, since this value has 0 decimal place, anything you are going to write in here is going to be written to 0 decimal place. So now your next thing is now to multiply and make sure that anything you write it to 0 decimal place. Now, after putting that largest, you do not consider now anything concerning significant figures. No, you just now consider number of decimal places. So when you continue, I'm writing. So when you continue place, you'll get something like that. 25 times 16.7, you'll get now. Take an example for this 25 times 16.7, you get your answers 417.5. But these are for significant figures. But since this one has already dictated that we must write to 0 decimal place, then it means here you round up and write 418. Then here we shall have 400. That is how you write. When it comes to addition, we always consider the number of decimal places, but we consider the lowest number of decimal places. When you look at this column here, it is written to 1 dp. When you look at this column here, it's written to 1 dp, meaning that any answer we are going to be writing here, since 1 and 1 is the same, it will be written to 1 dp. But let me say, if this column was written to 1 dp and this column had 2 dps, then you look at the lowest number of dps. So 1 and 2, the smallest is 1. So everything here, now you write it to 1 dp. So what are we going to do now here? What we are going to do now, anything we are going to write here is going to be written to 1 decimal place. So you start 20 plus 20, you get 40. You're going to write 20 plus 20, it's going to be 40.0. 25 plus your 16.7, you write 41.7. 30 plus 15, you write 45.0. 35 plus 14, you write 49.0. 40 plus 13.3, you write 53.3. 45 plus 12.8, you write 57.8. Now that is how you present your data when it is addition. But you make sure that all your values you are writing are written to the same number of decimal places. If it is 1, everything you do, you maintain it to 1 decimal place. You don't add anything on that. Okay, so that is what. Make sure you maintain 1 decimal place, 1 decimal place. Okay, we go to division. Now, when it comes to division, we still consider significant figures in division. Now, what do you need to look out? When you divide two things in division, what do you need to look out for? Now, in division, we call it a quotient. We call it a quotient. Quotient means a result when you divide two things. Now, in division, we always look out for the largest quotient. Largest quotient, you will look at when you divide two things, which one is going to result into the largest value. Take an example. Here we are dividing U out of V. What am I going to do? I'm going to come here. I look at my U here. I look at my V. I am going to first test this, and also I test the one down. Always, I encourage you to test such that you know. Now, allow me to write here that I have my U out of the V. But what is my U? My U is 20.0, and I'm dividing it by 20.0. What do we need to know? When you look at this, at the first one, how many significant figures does it have? It has 3 significant figures. What about the second one? It also has 3 significant figures, meaning that the answer you get when you divide, since 3 and 3 are the same, you have to write them to 3 significant figures. So 20 divided by 20, you are going to get 1. but 1 is just one significant figure. So you add 0.00. Then you test the last one down. The last one still, we are going to get U out of V. When you look at our U is 45.0. How many significant figures? 3 significant figures. When you look at the down figure, has 12.8. How many significant figures? 3 significant figures. Then the next question you are going to ask yourself, how many significant figures? What is the lowest that all of them have the same? Then check out now on your calc. 45.0 divided by 12.8. What answer do you get? That here, when you get your answer, it is 3.515625. But since 3 and 3 are the same, I'm going to write my final answer 3 significant figures. So I count. This is 1 significant figure, 2 and 3. So I am going to terminate at this point. But as I'm terminating, I'm going to look at the value that comes after it, that this value is 5. So it means I can round up and I write 3.52. Then I'm going to ask myself, down here, I'm getting my answers 3.52. Up, I was getting 1.00. Which one is the large value? That the downward value is the largest value. So that is the value that is going to dictate to how many decimal places I must write all my answers. So it means that all the answers I write here must be written to 2 decimal places. So anything you write it to 2 decimal places. And at that point, you do not follow the what? You do not follow now anything concerning significant figures, as long as you have obtained your value. So here we shall have our answers 3.01. The next one, 35 divided by 40, we shall have our answers 2.5. But this one has 1 decimal place, so you add on a 0. When you go to the next one, you have that divided by 15, which is 2. So you don't write 2 because you must maintain the number of decimal places. So you add on 0.00. You go to the next one, then you write your answer. Now the next one is interesting. You have 1.497. Now if I'm trying to 2 decimal places, you note that I'm going to terminate from here. But you note that this value can be rounded up. So it means you are going to come and say 1.4. But 9 plus 1 is 10. So it means that you cannot write 10, but you round up again. So it would be 1.50. So here I'll write 1.50. When you continue the next one, it's going to be 1. How with your values. The number of decimal places must match. The number of decimal places must be consistent. If it is 0, everything should be 0. If it is 1, everything should be 1. Allow me now to take one hand from Tina. Tina, unmute. Okay. Okay. I think okay. Tina, I failed to get you. Buembo Secondary.
So we have a question.
Yes.
I would like to ask that if I'm writing my results and I was told that when I write the first three answers and they are having a limit of jumping, like let's say that 2, the remaining will be the same. Is it true?
No, it's not. It's not, and I don't encourage you always to do that, because in science we need always to prove something. It's not about guesswork. you go on and verify that actually that's what you are getting. So I don't want you to do that guesswork. So go on and do things practically. Okay, allow me to continue. I will respond to the questions. Now, I know some of you at your schools, you have also done something concerning reciprocals. Now, I want you to take note that in case you are dealing with a reciprocal, take an example. When you look at my screen, I have given you an example of a reciprocal. When you look at the reciprocal, we have 1 out of V. Now, when you look at 1 out of V, 1 is a float. We call it a float value. It does not change. What do we look at? We look at V because V is the value that keeps on changing. What do you need always to do? Whenever you meet reciprocals, 1 out of something, 20 out of something, for such, if you are treating your value, when you are treating your value, what do you need to look out for? I want you always, whenever you are looking at the reciprocal, let me say you are looking for V, come in this column of V. Here, this is the column of V. Pick out the largest value here. You pick out the largest value in the column. So the largest value here is, when you check through, the largest value is 20. Now you are going to come and say 1 out of 20.0. Then 20.0 has how many significant figures? That it has 3 significant figures. Now, then you place your calculator. That 1 divided by 20, which is 0.05. Now, when you look at this value, this 0 is not a significant figure. This 0 is not a significant figure. So this value here has 1 significant figure. But your value here dictates that you are going to try to 3 significant figures. So what are you going to do? You are going to make this have 3 significant figures. So it means that you are going to come and say 0.05. But since they are supposed to be 3 significant figures, I'm going to add on another 0. Those are 2. I add on another 0. Now, anything you're going to write here down, it's going to be written to this number of decimal places. That this is 1, 2, 3, 4. Anything you write here, you write it to 4 decimal places. Now I want to repeat for this one. 1 out of U. Check in the column of U here. What is the largest value? That the largest value here is 45.0. Do the same. Say 1 out of 45.0. 45.0 has how many significant figures? That there are 3 significant figures. Now, the answer you write, you are going to write it to those significant figures. So, for this case, it's going to be 0.02222. So, since we want 3, 0 here is a leading 0. This is a leading 0. So, I'm going to write, I want 3 significant figures. So, I'm going to write 1, 2, 3. So those are 3 significant figures. So that is the first value I'm going to write here. I write 0.0222. And then anything that comes here is going to be written to the number of decimal places of this value. That this has how many? 1, 2, 3, 4. Anything you write here, you write it for decimal places. So whenever you find yourself that you are dealing with reciprocal, because I know when you are dealing with light, some of you plot 1 out of V, 1 out of U. So please take note on how you are supposed to treat that data. That whenever you're dealing with a reciprocal, we always look out for the largest value within a particular column, and that one, its denominator dictates how many decimal places our value should be written to. Okay, so let me take on one question from Andrea and Dalton. Okay. Yes. Others, you can place your questions in the chat. I'll be able. Okay. So we are going to continue. Allow me now to continue. Okay. So please, I want you to take note that when you are adding or subtracting, the smallest number of decimal places are considered. When you are dividing and multiplying, we consider the least number of significant figures. Take note of those two things. Okay. Now we go to data analysis a bit. Now under data analysis, I'm going to look at the graph. What points will earn you a mark or scores? Dear students, when you are looking at the title of the graph, I want you always that when it comes to practical, one, please go on and use graphical analysis. Don't use those things of averaging and the rest of that. Please stick to graph work. Now, number one, have a title on your graph. The title that you are going to come up with must be written on the graph itself. But please, when you are writing your title, let me say you have written a graph, you are going to say a graph of maybe UV against, and please take note that here we use against U plus V. The word is against. Don't use with. We use against. Here you pay attention. Number two, when you're writing a graph of UV, don't put units. Don't say UV and you put units. That is not correct. Number three, avoid writing a graph. Avoid writing this, whereby you are having A on the G. Avoid, this is not okay. You are going to miss out on the score on that. So please do not write a graph. Make sure that you separate the A and the graph and never put their units. Number two, the axes. Label your axes correctly with quantities and units. In case this is my axis and I have put here UV, put the quantity and put the units, that these are centimeters squared. Go to the x-axis. You label it very well that this is U plus V, and come and put that these are centimeters. That's what we call correct labeling of the axes with quantities and units where it is applicable. So you write quantity and units, quantity and unit, but not everything will have the units. Some will have, some will not have. So make sure you label. And when you are drawing your axes, avoid doing rough work. Some of you are hurrying and this is what you do. Some of you come and do this. Please avoid such axes. These ones here. Avoid drawing your end point of the axis like that. Let your end point be clear like this, like this. This is the correct way to draw your axis. But avoid having this hanging one. Avoid having this one here. Such. Do not have those when you are drawing your axis. When it comes to the scale, use a uniform scale on each axis. If along this axis you are using 5, make sure that between any two consecutive digits you have, the moment someone subtracts, it is saying that it is 5, 5. If here you have used another scale, make sure that the moment someone gets two values and they subtract them, you get the same value. So here your scale can be different, it can be different. Sometimes you may find that they are coinciding and they are the same, which is very, very okay. So please pay attention to that. And I want to let you know that the convenient scales are 1, 2, and 5. However, when things have failed to work out, you can go in for 2.5 at worst. Now, do what we call demarcation. Mark and label the starting values. When you are labeling your graph, let me say this is your graph. Avoid putting here, let me say 0. And then you say 1, 2, 3. Show the starting point clearly. That my starting point along this axis is 0. Here it is 1. Here it is 2. Here it is 3. Come here, even if here it is 0, starts 0, 1, 2, and the rest of that. Have clear, distinct starting values. And when you are starting, please have that demarcation. Those are what we call the demarcations along your axis. Let them be clearly seen. When you are plotting the points, you can either use a dot with a circle, or you can use an X. Those are the recommended one. A dot with a circle or an X. Avoid doing this. Some of you do that. Don't use this. If you have decided to use X, just say X. X. Yeah. Then, for line of best fit, there, I repeat, it's not a mandatory to start with a 0. Your values here can start from any. You can even start from 25. You have 30, 35. This axis can start from 100, 200, and the rest of that. Unless you have intercept. That's when you can start from 0. When it comes to labeling your axis, I've said put the quantity. In case this is UV, put the quantity and say centimeters squared. Here we put the quantity and we put the units. You put the quantity and you put the what? The units. The same here, you write U plus V, put the quantity and also put the what? The units. That is very, very okay. Okay, so that is about now the graphical work. Now, on the graphical work, I was still talking about the line of best fit. The line of best fit, let me say this is your graph, has a number of definitions. It can be that line that goes through all the points that you have plotted. That is very okay. The line of best fit can be that line that leaves an equal number of points on both sides. It may not go through any, but as long as it has left an equal number of points on both sides. A line of best fit can be that line that goes through many of the points but leaves unequal on both sides. It can be something like that. So, if the points you have plotted are odd, you may not have balanced points. But if your line is not coming out, never have here 3 and you don't have any here. At least have 3 and have 2. That is proportion. But never have here 7 along this side and the 2 are not touching. So you must always balance your line of best fit. Okay, we come to the graph. We come to the graph. In case this is your graph and you are drawing this graph, I want to bring to your attention 2 things. Let me say, this is the graph I've drawn and this is the graph. What am I going to do? Let me change maybe the color. I think some of you may not be able to see it clearly. Let me use red. Let me say this is the thing and this. So what am I going to do? I have said have your axis like that, the same thing like this. When I'm writing my title, I'm going to write it above this, above here, where my axes have stopped. So I'll come up there and I write that this is a graph. A graph, don't underline, there's no need why you underline. A graph of UV against U plus V. So you come here, you indicate that this is your U plus V, and maybe here the units are centimeters. That maybe this is your UV and the units are centimeters squared. The demarcations I'm talking about are these ones. Every after 2 centimeters, put clear demarcations. Every after 2 centimeters, put those clear what? Demarcations. That's what we call demarcations. When you demarcate your values, I want you to go on and clearly put those values. Let me say here you started with 100, put 100, 200, 300, 400. That is okay. In case here you started with, let me say 0.2, you say 0.2, 0.4, 0.6, 0.8. When you are plotting, in case the point is here, you put your dot and then you put a circle. Okay? You put your dot and then you put the what? The circle. You put your dot and then you put the what? The circle. So afterwards, I will expect you to come and then draw your line of best fit in case this is your line, something like that. Now, what am I expecting you? Let me just place here just one point. What am I expecting you? After drawing your line of best fit, we must go on and draw our what? We must go on and draw our right angle such that we can be able, I must be able to do what? In order for us to come up with a slope. So I want to let you please to take note that when I'm drawing my right angle, it should be able to cover all the points I have plotted. So I can come here and I can come here. And please take note that always that one is a bold line. Don't use a dotted what? A dotted line. So I can have my slope like that. I have said you put the title in the graph, but above your axis here. Let your axis end here and your title be above within the graph. Okay, now that is how I expect to come up with your graph, very clean and clear. Now, I'm going to talk about how to read the values for the slope at a later time. Okay, so please take note of that. Here, when you look, I've given you a sample graph. I've given you a sample graph that you can look at. When you look here, you can see that this is my sample graph. When you look at this sample graph, you can notice that I have labeled my graph very well here. So this is one of it. When you look here at the axis, you notice that I have labeled it very well. When you check my point here is very good. When you check my end point here is very good. When you check this line I have drawn here, you notice that it is a bold line. Now, what do I want you to know? If for your graph to qualify to be at least 3/4, always ensure that your vertical here, it is at least 12 centimeters. When you count the number of centimeters, let me say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Let it be at least 12. Along here, at least make sure that it goes above 8. That's when it will be 3/4. Now, this is just a sample of the graph that you can have. But I want you please to take note that along this axis, as you are writing your values, have a consistent decimal places. In case here your value had 2, let every value you have here be to 2 decimal places. If along the vertical your values had 1 decimal point, let all them be to 1 decimal point. Now, how do we read these values here? Here, these values at this point are always read basing on the smallest value, on your graph. Please take note of that. Yes, but that one I'm going to throw more light when I reach at that point. So, I have said when you are determining the slope, ensure that it has covered at least 50% of your graph. That is number 1. Number 2, it should not touch any of the plotted points. Any points that you have plotted, it should not touch. So you take note of that whatever thing you are doing, it should not touch those particular points. Okay. It should not touch those particular points. Okay. Then it should not touch the plotted points, and it should touch 2 points on the line of best fit. Okay. So that's what I'm going to display here. Now, give me 1 minute as you read through one. Okay, I think now we are going to start. Now, this is where I want you to understand how we read the values. How we read the values. I'm going to first stop sharing such that I make it very clear on how we read the values, because that is a very important thing, reading the values on the graph, because some of you don't know how to read those values. Okay, allow me, I'm going to expand a bit. Just give me a minute. I want to show you how you read those values when you have your slope, and how you must read those smallest values, because they are very important, and many times some of you do not read them the right way. Now, when you look at my graph, I have made my graph bigger such that we can learn how to read them. Now, when you are reading these values here, this is my point here. When you look at it, what do? I'm going to write, this is my vertical. This is my vertical. What do you need to do? You need to find out this small box here. How does it, we call it the least count. You look out for this small box. So to get that small box, you look at these 2 values you have used. So I'm going to say 1.0 minus 0.9. So when you check 1.0 minus 0.9, you get your scale as 0.1. It means that the scale I used here was 0.1. But I ask myself, in many boxes do I have? These small ones that I have 10. So I will come and say 0.1 divided by 10. So when you say 0.1 divided by 10, you get your answers 0.01. What does it mean? It means that the values you are going to read along the vertical axis must be written to the number of decimal places of the list box. Here the list box has 1, 2. So it should be written to 2 decimal places. So that means that the value you are going to read here for y must be written to 2 decimal places. When it comes to the horizontal here, you notice that this person, we had 0.45 minus 0.40. When you subtract those two, you get your answer as 0.05. But in this, I'll divide by 10. So when you divide by 10, you get your answer as 0.005. Now this one has 3 decimal places. Now, any value you read along this axis must be written to 3 decimal places because that is the least count for that particular axis. Please take note. That's why here when you look at this value was written to 3 decimal places. So you always pay attention to that. You pay attention to that. So I don't know. I want to pick on 2 questions. So I'm going to start from Otubali and then Geoffrey Insigoma. And then Smag, one of you, and then maybe Ngarama, girls. Yes. Oh, if you are not talking, I'm going to mute you. Come again.
Master,
Yes.
you were like, we should not touch any of the plotted points, right? But then again, in your second
Yes.
verse, you brought that we should touch 2 of the plotted points on the line of the best fit. What do you mean? I'm confused.
I repeat. I've said that the line of best fit can go through all points. The line of best fit may be that line that doesn't go through any of the points.
In my question, you
Yes.
in the point you gave us, you were like, we should not touch any of the plotted points. And then in the second part, you gave us like, we should touch 2 of the...
What it means that when you are drawing your slope, are you getting it? Don't use these points you have plotted, this point, to come up with your slope. That is the meaning. Have you understood? That's the meaning of that statement, that don't use these points, because some of you have a tendency of just coming here and here, something like that. So I'm saying don't use these points when you are coming. Then that says that at least have 2 points, it means that when you are drawing your line of best fit, do your best to have at least 2 points you have got, at least touch your line of best fit. Hope you have got the difference between the two. Okay. Sent us. Okay. Ngarama SS. Light vocation.
Yeah. I wanted to ask you whether we represent the scale after drawing the graph.
No, the scale is always scored from how you have presented your values along the axis.
Thank you, sir.
Okay. Okay, I think I'm going to continue. Kindly have your questions in the chat. Can we put the name of the axis? No, there is no need for you to put y-axis, x-axis. The moment you put the quantity and the unit, that is enough. When do we start with the non-zero digit? As long as we are not going to get the intercept, you don't need those 0 digits. You can start from any value. On the reciprocal, do we consider the biggest value of V? Oh yes. And whenever we are dividing, we consider significant figures. So where you had 1 out of V, you consider the number of significant figures of V, of the largest value. That's what dictates. Can I add marks when I don't indicate the scale? the scale is marked on how you have put your values here. That is what they look out for. And labeling the axis is very key. Labeling them with quantities, not putting y and x-axis. Where are we going to get 1 out of u, 1 out of v? For light experiments, depending on what you are going to be plotting, you'll find those values there. Is it a must to include those values? In your table of results, you must have at least 5 values. Is it okay to leave 2 centimeters on every axis? It is very okay, as long as your graph is fitting. Is it a must to show the working over of how you have obtained a scale? No, it's not a must. And that one, do it as your rough work. Do we put the title in the graph or above it? Above the axis, but on the graph paper, not in the white space. Why do you leave 1 centimeter? Now that one depends. If your graph is not fitting, you can leave 1 centimeter. If your graph can allow 2 centimeters, it is very okay. How do we obtain the scale? I'm going to come to the scale. Is there a penalty for a student who draws a dotted line? Yes, there is a penalty. So let children, when they are drawing the right angle triangle, use bold lines. Yeah. And between the plotted point with that, yes, all points must be covered. When you are drawing your right angle triangle, it must cover all the points you have plotted. So that's why leaving 2 centimeters that side always caters for that. So it must cover all the points you have plotted. How do we get the scale on the graph? I think I'm going to talk about graph work. I think the line of best fit should cross one of the axes. No, unless when you are finding the intercept. That's when it can cross. Your title should be in the middle. Your title should be in the middle of your graph. Okay, I'm coming to the scale. I'm coming to the scale. I'm coming to the scale. Okay. Yes, please take note when you are writing your values, make sure you write them at directly at the demarcation point. Some of you are rushing and you find yourself writing the values here. So please make sure your values are written. Okay, I think other questions, I will respond to them because we are continuing with the work. Okay, so we continue. I have talked about that. Now we go to our report. Dear students, as we are writing our report, you will find that they have given you a hint in the practical. But please do not think that the hint would always be there. Much as they are going to give it to you, but it is also very important to learn or to know the flow of the report. Know what the aim is, the hypothesis, the variables. And now we are going to start our report. Now, in the report, as you write your report, the first thing you always write is what we call an aim. Your aim is that statement that describes the quantity and the purpose of carrying out an investigation. Please and please, as you carry on this particular investigation, your aim must clearly state what quantity. Are you looking at focal length? Are you looking at resistance? What is it that you are looking out for? It must come out clearly. Number 2 is the purpose. Why are you determining that? So, in other words, always identify the problem within the scenario. Because you carrying out this investigation, there is a problem you want to solve. So the aim must clearly bring out that feature that there is something you want to solve, there is something you want to find out, and there is a reason why you want to find it. So the two things that should always appear in order for you to get the maximum score of the weight of 6, it is you must have the quantity and the purpose. What are some of the wrong aims? Some of you right. Take an example. If you want to get a low score on your aim, is you just writing an investigation to determine the focal length of a concave mirror. When you look at this, the person has told us what the quantity is. The person is determining the focal length, which is okay. But when you look at this aim, the person has not told us what is it that you are finding, for what purpose is it. Why do you want to find the focal length of a concave mirror? What's its use? What's the purpose? What problem are you solving within the scenario? Now, this one, you are not going to earn a complete score. They will just say, this person deserves a 2. Some of you just write to determine whether concave mirror is suitable for use in reflectors. Here now, this student has given us the purpose why he's doing the practical, but he has not told us which physical quantity are you measuring, which physical quantity are you going to investigate. So here, still, you are not going to earn a maximum score. You'll earn only 2, and they'll move on. Now, in order for you to earn the maximum score, you must be in position to clearly state the aim and the purpose. You must clearly be able to state the aim and the purpose. Once you are able to state the aim and the purpose, then it means you can get the maximum score. So please pay attention to that. It is very paramount. It is very important. Some of you come up with aims that are not related at all to the practical you are doing. So for such, you don't get anything. They give you a big 0. So whenever you are writing, make sure that you reflect what it is about. But the moment for you come up with, and there is no any way it is related, then it means you are going to earn a big 0. Make sure that whatever thing you are writing, it is related to the scenario. Ensure that that particular thing that you are writing, it is related to the scenario and it clearly shows the purpose. It must be able to show the purpose, why you are doing so, and what quantities are you going to measure. Once those two things are clearly seen, it means that you are going to be able to get a maximum score. But the moment those two things are not seen in your title, it means that there is no way you are going to have your maximum score on that. So please, whatever thing you are going to do, ensure that those things are clearly seen and that you have been in position to clearly put them with their clear outline. Okay, now that one is clear. We are going to continue. Now, how do you state a good aim? How do you state a good aim? Now, when you are stating a good aim, I want you always to have two things. Number one, what is it that you are investigating? Number two, clearly give. It is about resistance of a fuse. Clearly tell us the investigation is about resistance of a fuse. This is the physical quantity you are looking out for. And why are you doing it? Purpose means why are you doing it? Why are you determining the resistance of a fuse? To confirm whether it is suitable for use in a phone charging. That is the reason. So if I'm giving a complete one, this is how I'm going to find it. That is how I'm going to. Please make sure that you know the difference between the two. when I'm determining the refractive index, index, that is the investigation for use during physics practicals. So how can I write my aim? I can say an investigation to determine the refractive index of a glass block. Why? In order to determine whether it is suitable for use during physics practical lesson. And please, I want you to take note. When you look at my wording, I'm using scientific investigation. Some is scientific investigation, or you can say an investigation. It is very okay. I want you to take note that there is a difference between saying an experiment. When we talk about an experiment is a controlled test to validate an hypothesis. But when we talk about an investigation, is an inquiry to gather information, to uncover facts. That's why here I'm not using any word about experiment, but I'm using investigation, because there is some inquiry, there is something there is some information you want to uncover. In case you are determining the focal length of a concave mirror, tell us why are you determining it? And then from there, you can give us a complete aim. A complete aim should be able to state for us the quantity, the physical quantity, and why you are doing. This is when you are going to get a complete score. So please and please, whatever thing you are doing, please ensure that you look through and have something complete. Have something very complete. Make sure that your investigation, whatever thing you are coming up with, has the purpose and has the investigation that you are trying to work on. Okay, hope that is very clear when it comes to the title. Please, when it comes to the aim, ensure that those things come out clearly. Ensure that you are in position to write those things very, very clearly. Okay. Okay, after that, now we are going to move on. But that is how I expect you to write a good aim for your experiment. If your aim is not like that, you are not going to get a maximum score. And when you are writing your aim, don't put values there. We don't expect you to tell us refractive index of this. We don't put the values. The only thing, what is it that you are going to investigate? Remember, it is an investigation. You don't know yet what is the actual thing. So we do not put values, we do not put range and the rest of that. Okay, I've given you an aim that is okay. We continue. Now I have a sample scenario. I want you to read through the scenario. Whenever you receive the scenario, I want you to check out what is this scenario looking out for. I want you always, dear students, to obtain the purpose of your investigation, to obtain the purpose, always check out the task. The task even is going to give you a hint that design and carry out an investigation to determine whether the glass block satisfies the required specification. So you can read here and know now what is the purpose. Now to obtain the physical quantity, read the scenario. The scenario, you'll find that they have given you a hint where you see range values. The procurement committee, the glass should have refractive indices. Now here where you see the ranges, the range of values is where you need to look out for the quantity that you are going to write or to put in there. So may I ask any school to tell us now, if this is our scenario, how can you draft an aim? I want only people who are putting up the hand. If you are not putting up a hand for the aim, kindly do not. So I'm going to start from St. Francis. St. Francis, unmute and tell us what would be your aim. Yes, St. Francis? Oh, am I failing to get St. Francis? Okay, if I'm failing to get St. Francis, let me have Mariam High School. Oh, Mariam High School.
She's coming.
Okay.
Oh, okay. I was asking about the aim. Can you replace
Yes.
whether with if?
Come again?
Can you replace whether with if? Like, what's the value in the aim? Yes, can you say the value in the aim? The value in the aim. Confusing.
Oh, I think I'm getting okay.
Yes.
Saint Elizabeth, don't include the values in the aim. Okay. Saint Elizabeth. Oh, I don't know. I'm failing to get Ngarama Girls. Oh, yes, Ngarama. Okay, Ngarama SS is not talking. Collido Comprehensive. I want to draft. Those who have finished, you can even put for us.
Good evening, sir.
Yes, good evening.
I'm stating the aim of the experiment.
Okay.
An investigation to determine the refractive index of a glass block in order to determine whether the glass block satisfies the required specification.
Okay. Thank you. Thank you. Good. So that one can be your aim. Okay, I have another scenario here. Let me have another school. Power in Christ. Power in Christ. Power in Christ.
To determine the
Yes.
aim, I mean investigation. An investigation to determine whether in order to be used to
Come again. What is the physical quantity?
an investigation.
What
To
are you
determine whether
investigating?
an
No, you need
investigation
to start with
an investigation
yes.
to determine whether the spring
Yeah. Now, like I've said, power in Christ. What you have, you need to have the physical quantity. What is it that you are going to be determining in the experiment?
an investigation in order to determine the force constant of the spring.
Okay. Now you have mentioned the force constant, but your purpose has not come out very well. Your purpose has not come out very well. Okay, I don't know whether someone there at school wants to help you. Promise High, do you want to support? Promise High? Oh, Promise High, you are not unmuting. Rena College?
A scientific investigation.
Okay.
To determine the force constant of the spring. In order to satisfy the required specification and advise the work manager. Where is that?
Can you make it much better? Your purpose should come out clearly.
A scientific investigation to determine the spring, the force constant of the spring in order to satisfy the required specification and advise the workshop manager.
Okay, a bit, but always make sure you understand what problem is within the scenario. What does the scenario want to solve? Okay, thank you. The last one is here. I don't know which school. Thank you, Rena. Kisoko High. Kisoko High. Okay. I think Kisoko High.
Yes. Okay. Thank you, sir. The aim is an investigation to determine the internal resistance of the dry cell, so as to determine whether the dry cell satisfies the required specification.
Okay. Thank you. Thank you. And now you can go on and tell us which you could go on and tell us. Okay. Okay. Thank you so much. Now that is how you start your aim. So your aim should clearly bring out the investigation and avoid writing things of experiments. Always look out for investigation. So I'm going to ask someone to type in the chat, those who can. This is the trial item we are going to use. This is the trial item we are going to use. So I want people to draft in the chat quickly. What is the aim? We are starting now, dear students. We are starting now on our report. We have started now on the report. Now, can you write your aim in your book? Write your aim in the book. For this item, we are going to score ourselves. Write your aim for this item. Don't write the item. I want you to just write your aim for this experiment. Right? Okay, Bilal, I'm not seeing your question, but let me check through. Don't use capital letters in the title. Use small letters, because that is like a sentence. So don't use capital letters. You can write, but I don't advise you to use capital. Okay, hope all students have written now. Don't use red pen. I was using red pen such that the work is clear. So let me hope you are finished to write your heading. Please use a pen strictly. Don't do any graph work using a pencil. Okay, hope you have finished. Write your title, dear students. Okay, now this is the title. You can, if you have this, kindly let us know in the chat. When you look at this, I have clearly showed you that an investigation to determine what are you looking out for. Focal length. This is what they are going to looking out for. To determine the focal length of a concave mirror. In case it is a lens, you say a lens. In case it is a glass block, you tell us a glass block. Why? In order to determine whether it is suitable for use as a reflector in vehicle headlights. That is where I told you that always understand the problem. Understand it from the scenario. They told you here, when you look here, when you read through, what do they want to use this? What do they want you to use this concave mirror for? They want to test whether it can be used as a reflector. So you need to understand such that when you're writing your investigation, you can clearly tell us the purpose for that. So this is how you can now, clearly write that particular thing. Okay, we are going to continue. Number 2, on our report, we have what we call an hypothesis. An hypothesis is what do you expect to find? What do you expect? What is the guess? Sometimes they call it a scientific guess. What you expect, what you think you may get out of the experiment. That's what we call an hypothesis. Now, dear students, when we are stating an hypothesis, one of the key things that should come is the physical quantity. The physical quantity can be refractive index, it can be focal length, it can be force constant, internal resistance, acceleration, mass, and the rest of that. Mention that physical quantity in hypothesis. You must have the range of values. Give us a range of values. Don't be specific on one value. Give us a range where you expect your values to be. Where are your values going to be? Maybe between this and this. Third, give us a testable statement that the internal resistance of the dry cell is in the range of, and if that quantity has units, put the units there. Number 3, it should be consistent with your aim. If in your aim you said you are determining focal length, now don't change and bring in other things that may be magnification, this, the other, and the rest of that. Stick to what your aim was saying. So, please pay attention to that. Even when the range is not given, you can give your guess. If they don't give you a range, give yourself a guess, as long as you know the physical quantity. Because the use of an hypothesis is just a scientific guess that your answer can be like this or this. So it can be valid or invalid. So you can prove it true or not true. So it's not a must that always your conclusion is valid. Sometimes the hypothesis can be rejected. Okay, we continue. I can give you an example. Now, for the case of what we have been looking at, I can say that the focal length, this is the physical quantity of the concave mirror, is in the range 9 centimeter to 11 centimeter. That is what we call the aim. The focal length of the concave mirror is in the range of this and this. If if you don't want to use in the range, you can say is between 9 centimeter to 11. Remember, an hypothesis, you are just carrying it out. So you can say the focal length of the concave mirror is in the range of this and this. So here, your tense does not matter. Please, because you are going to find out whether it is true or false. So that's how you can state your hypothesis. Okay. So here, instead of, you can say in the range, or you can say between 9 centimeter to 11 centimeter. It does not have a reason. Don't put anything like a reason. Like I've said, don't attach a purpose on the hypothesis. Do not attach. The purpose is only attached on the aim. Yes. What if I say is from? Because you are not sure where it is starting from. Because you can say from 9 to this, yet actually it is not from there. So that's why it is always to say is in the range or is between this and the other. So take note of that. Okay, then from there, we are going to continue from hypothesis. Don't forget, in case they have given you units, you include also the units. From an hypothesis, we have what we call variables. Now, when we talk about variables, we have basically 3 variables. And I want you to be very careful with the 3 variables. We have what we call independent variable. Now, independent variable is the one you are going to be changing during the process of the experiment. Now, for our case, is the objective distance. And when you are stating your independent variable, tell us objective distance and put what are you going to represent your objective distance with, that it's going to be represented by you. In case you are talking about the dependent variable is what changes whenever the independent variables change. For our case of the mirror, we are going to have the image distance and put what you are representing, that I'm using V. When you look at the room, because I'm going to show you this experiment a bit more practical here. When you look at the room where I am, always we have what we call control variables. Now, control variables are the ones that may affect your experiment. One of them, I'm going to stop sharing my screen and I'm going to focus on the light experiments. So when you look at my screen here, okay. When you look at my screen here, I don't know whether, yes. When you look at my screen, when it comes to light experiments, some of the things, let me first remove this thing. When it comes to the light experiment, some of the things that affect our results. One, it can be how bright the light is in the room. When you look at my room where I am, you notice that the room is very bright. Sometimes, some of you have your windows open. You can find that the windows are open. So meaning that a lot of light is entering inside your room. So that means that now for such, you are going to have issues. Number 2, sometimes when some of you are fixing, you are looking at things, maybe these materials you use, sometimes they are not so good. So one of the things that we are going to look out for is that whenever there is a lot of light, whenever you are doing things concerning light, you need to reduce. So you have to reduce that amount of of light. Now, those are some of the things you need to know that you have to control if you are to get good results. Okay, so allow me now to go to the control variable. Now here your control variable is going to be light intensity. How much light is entering into the room? It can be EMF of dry cell. Sometimes the dry cells you are using are very old, so you cannot be able to generate good light. Now these are what we call variables. Then we have materials. Variables are scored. They will give you a score for the variables. However, I want to bring it to your attention that we have also what we call materials. When it comes to a minute. When it comes to materials, they are not going to give you a score. However, I will always encourage you, have your materials there. But when you are writing your material, I would always advise that have a quantity and a material. In case they are dry cells, you set to dry cells. But when I refer to quantity, have the digit and the digit, yes. So that is what I'm calling the quantity. And make sure that all the materials you have mentioned that you go on and use those materials. Then from there is we have what you call the experimental setup. Now the experimental setup, it depends on how are you going to obtain your result. For whatever experimental setup you are coming up with, always ensure that that experimental setup, one, it is well labeled. Make sure that whatever thing you are using, it is what? Well labeled. That is very, very what? Very important. Make sure that in case you are using a mirror, you label that this is a concave mirror. In case you are using a lens, you label very well. In case you are using mass, you label very well that this is maybe mass. So for whatever thing you are going to use in your experiment, make sure that that experiment is well labeled. Now, what are we going to do? In case this is my thing, I will come here. I'm going to just draw something. So I'll have here my screen, but I don't want to draw something. I'm going to let me stop sharing, and I want you are going to focus. I'm going to show you this. I want you to focus. You are going to look at my screen. Okay, I'm showing you something on my screen. Hope now you can see my screen. I'm not going to use chalk because I want to show you practically. When you look at my table, on my table, you can notice that on my table, I have, this is my ruler. This is the meter rule. I think, let me see. Okay, this is the meter rule. This is my white screen. This is the cell holder, and it has 2 dry cells. This is my mirror holder, and when you check inside there, I have my mirror inside. This is my bulb that I have connected. So what am I going to do? Always, I'm going to organize my experiment the way I want. So I'm going to come here, that this is my mirror that are you able to see my mirror? Okay. I want you to be able to see my mirror. Okay, you are going to see it, don't worry. Okay, this is my mirror that you are seeing this side. These are my dry cells. So I'm going to connect my lights. So I'm going to connect my light. So always connect your things very well. So I'm going to connect my lights. And I think you have started seeing that my light now is lighting. So what am I going to do? Now for such experiment, this is your mirror. It's going to be on one side. Okay, my mirror is going to be on one side. And then I'm going to come and I have my cell. This is my white screen. This is the mirror. This is the bulb. And this is going to be my white screen. So what happens is that here for such experiment, you need to ensure, let me make it very tight, such that. So what are you going to move? This pod here is the one that you move. You move this white screen. You fix the distance from the object, from the mirror. This is a mirror. I'm going to fix my mirror distance, and I fix the object. Then I start moving this until when I form a sharp image. When I move, hope people have started seeing the sharp image on it. So there is a sharp image there. But allow me to put my mirror far such that now that image can come out very, very well. So you move. Okay. I need to fix it again. Okay. Okay. I want to move such that. So when you look at my screen, you can see an image. An image is somewhere here where I'm putting my thing. Now, that you need to locate, I think, because it's getting a bit dark where I am. But when you look at my screen now, you can see some image there. But when you look at that image, it's not a bright image. The image I'm talking about is this image here. That is the image of the bulb. So it's not. So what do? You continue moving. When you move closer, you are seeing that now it's not becoming dark. So you move, you continue pulling until when you see that image, when it is very, very sharp. You continue moving. So until when you get a sharp image. Now, that is what you have always to do. Whenever it comes to these experiments concerning what? Concerning light. You make sure that the object distance is fixed. Your bulb, which is the thing, is always put in the middle. And always your task is to move until when a sharp image is good. But this is how you set your experiment. You make sure that you have your mirror. This is my mirror. Let me place them here such that you can see very well that this is my mirror here and the mirror holder. This is my touch bulb and this is the white screen. In case maybe your thing is not, you can even place this at the what? You can get something to hold for you such that your bulb is a bit far. And then what you'll do, you'll continue just moving this white screen until when you get a sharp image. So that is how you can have your experiment set out for you. So please, that's how we can set that experiment. But one thing is that the white screen is going to be here. You're going to have your bulb here in the middle. You'll have your mirror this side. And then the only thing you have to adjust this until when you see a clear, sharp image being formed on your screen. So that is the setup of the experiment. So that is what now I can go on and draw. So that is what I'm going to go on. You can use one dry cell or you can use two. Two dry cells. And now members are asking, what is the object? Now, your object is this bulb. The bulb is your object. Then the distance between the bulb, this distance here between the bulb and where the mirror is what you call the object distance. So the distance between the bulb is the object. This is the object, is the source of light. Then the distance between the bulb and where the mirror is what we call the objective distance. Then the distance between this mirror and where the image is formed on this white screen here is what we call the image distance. So I'm going to come up here again. So hope now it is clear. In case not clear, okay, now I think I'm going to. Is that the only way to make up the experiment? No. The other way is using the wire gauze. Using this. Using this is another way to do it. Whereby you are going to fix in here. You are going to fix in here. And then that is another way you can make it. Using the wire what? The wire gauze. But this one, I felt it is a bit much easier for you to do. But you can use other approaches. Even in lenses, it is the same. Even the lenses, you'll arrange your experiment almost the same. Yeah. Okay. I'm just looking through the chat. Okay, I'm looking through the chat. I'm looking through the chat to see whether there is any. What about us who use the desks? What if the image is very far? No, you'll find that we are going to use the meter rule. When you look at my thing, the meter rule, let me say, when you look at this is your mirror. So the use of the meter rule is to help you measure the distance between the object and where your mirror is. So the meter rule is only going to be used when you are measuring this distance between the object and where your object is. Then you will also use it to measure the what? The image distance. So when you look at this, okay, I don't know whether you'll be able to see, but let me try to change and you look at. When you look at that, let me hope you can see something. When you look at that, what I'm showing you, you can check that this is my mirror here. This is the object, and that is the what? This one here is my white screen. So what is happening is that when you move this thing here, rose, you notice that you are seeing something on the what? You are seeing an image, but it's not sharp. So you extend it, you move it to and fro until you get something very sharp, like what you are seeing there, like what you see there on my screen. So the next thing you do, you measure this distance. You measure the distance from here where your mirror is, from this point where your mirror is, up to where here the image has been formed. So that's how you do it. You measure the image distance is the distance from the mirror up to where the image is being formed. So that's what you do. So up to when you get that. Then the object distance is this distance from here where the bulb is, up to where your mirror is. So that is what now we are going to draw here on our setup. Okay, so allow me to disconnect my setup here, and then I continue quickly such that we can be able. So when I'm drawing my setup, like the way you have seen the setup, how the setup was, that is the same way I'm going to do it, exactly the way it was. that on our setup, I'm going to come here. You use a ruler that here you had your white screen. So you label that this was the white screen very well. Then on the white screen, you can say that here in the middle, I had my bulb. So you have your bulb here, that this was my, this is my bulb. Then on the bulb, you notice that you had the cells, you had a switch. So you can come here, have your switch, you can call it K. Then you had your cell bulb, something like that. Connect it there. Then come here, you had your meter holder. I'm drawing it roughly, but for you, draw it better. I'm just showing you what you are going to do. Then from there, you have to indicate on your drawing that this is my object distance. The distance between the bulb and the mirror is the object distance. Then the distance from the white screen up to where the mirror is your image distance. So that is how you can draw that when it comes to that. So that is the rough sketch of your thing. But for you, you make it much better than mine. Okay. From there, you are going to write up your steps of doing it. So I can say that the set of apparatus were arranged as shown in the diagram below or above, depending. Then from there, look at the tense where. So we are using past tense. Whatever thing you are doing, use past tense. The object distance, this is why I want to emphasize, the object distance U, the moment you mention object distance U, was adjusted until it measured 20.0 centimeter. Remember, a meter rule uses 1 decimal place. Using a meter rule, now give the equipment you have used to measure. So once you mention the quantity, give also the instrument you are using to measure. Switch K was closed. So you mention the apparatus and what symbol you are using. The position of the white screen was moved to and fro until the sharp image of the torch bulb was obtained on it. Then from there you say the image distance V between the mirror and the white screen was measured. I want you to take note, the moment you mention measured, what did they use to measure? That I used a meter rule and I recorded my value. So when you say image distance, what image distance? You put that particular quantity. Then you say steps B to E were repeated for the values of U, 25, 30, 40, 45. And like I've said, always make sure you have at least 5 repeated values for your steps. 5 repeated, but 5 of them. The switch is not called K. You are using the letter K to represent your switch. So it is not that you must always use K. You can use any other letter of your choice, depending on how you have labeled it on your setup. Then you can say results were tabulated, including values of UV and U plus V. Then from there, you talk about a graph, you talk about a slope, and then you make your conclusion. Now, these are the steps. These are the steps. So I want you to mention the quantity, what instrument measures it from what you have. Now, these are the steps you can look out for or you can use when you are writing your setup steps on how you carried out your investigation. Hope that is okay. That is very, very okay. So that's how you can write your clear steps. These same steps, you can apply the same between this and the in here and when you are dealing with lenses. The same thing, you can look at them. So they can be almost the same. But I want you to know that here I'm sticking to steps that I followed, the steps that I used, not procedures. Procedures, like you know what you are doing. There's a difference between the steps and procedures. Procedures is like you are following something. That's what you call a procedure. You know what to do. From here, you go to this. From here, you are doing this. But when it comes to steps, it means that there is some investigation that you are doing. So that's why I always encourage that you use the word steps. That I moved from this step, I went here. Yes. So procedure means something that is official, the official way of doing something. That's why I don't encourage you using the word procedure, but steps. So of procedure means that is the official way. That is the plan. That's the method. But here you can look at other ways to do these things. So hope those steps are very clear to everyone. And I think we can now move on. Please, I repeat, use past tense because a report, when you are reporting about something, it means that you have already done or you have already experienced that. Okay, so I'm giving some 2 minutes for schools that are still writing. So let me be responding to some questions I'm seeing in the chat. Why do we calculate 1 out of it's not used? I was showing you data treatment. And it depends on the school. Some of the teachers use 1 out of U plus 1 out of V. Other teachers use UV and U plus V. Yes. Yeah. Remember, please do not cram. I want you to understand. From 1 out of F is equal to 1 out of U plus 1 out of V. Some of your schools are going to use this kind of thing, whereby you have 1 out of U is equal to 1 out of F minus 1 out of V. Whereby your teacher has told you to plot, this is your Y maybe, and this is maybe your C plus MX. So there are schools where that are going to plot Y as 1 out of U, that are going to plot 1 out of V as their X, and they will get their gradient as -1, and they are going to get their intercept as 1 out of F. So it depends what your school has taught you. That's why I had to bring in the 2 issues. It is not a must. Some you can plot because remember that when you have 1 out of F is equal to 1 out of U plus 1 out of V, this is the same as 1 out of F, V plus U out of U, V. What does it mean? It means that this, when you cross multiply, you have UV is equal to F into V plus U. Now, if this is your Y and this is your MX plus C, it means that your intercept C is 0, your M is the F. It means M is your F. Then it means that your V plus U is your X. That's why here I have plotted Y as UV and X as V plus U. But in case, because I know in case you don't use this approach, then in case you want to plot the other way around, it is also very okay. In case you want to plot, let me say, for those people who I know some of you wanted to plot this. Let me say, in case you go in for this, whereby you have UV out of, this is 1 out of F is equal to V plus U. If you are to plot this, it means for this case, this one can be your Y, and then you come here, you say this is your M, and this is your X, then plus C. Still, it means your C is 0. But for this case, your gradient M is going to be 1 out of F. So your slope S is going to be 1 out of F. In case you put V plus U here along this axis, then here you have your UV as your X. it means that for you, your slope, you will say slope is 1 out of f. So let me hope that is okay. Can we use the torch bulb as the object? Yes. Yes, we can use the torch bulb instead of the wire gauze. Is the graph of u plus v against? Yes, I've showed you how it comes. But here, your conclusion for the slope, you will say now, your slope is 1 out of the focal length. That's where now you need to take the distinction. Procedure. Yes. Remember, you have already made your setup. So here, when you are repeating the steps, there is no need for you to put here from A to E because the setup has already been done. So that's why we start from this step up to this step here. Which step? The tense is past tense. Is past tense when we are writing our steps. Okay, we are going to continue. Next, we have what we call the table of results. Now, in our table of results, let me say this is our table of results. What are we going to do? In our table of results, for this particular experiment, when I did the experiment, this is what I obtained. So here, I had 19.8. Here, I'm going to use what I got. This was 16.6. This was 14.8. This was 14.0. Here I got 13.4. And here I had 12.8. Now, like I told you that if I have U times V, here it means that I'm going to use significant figures. I'm going to multiply U times V, but I first look out for the largest product. So here, this one has 3 significant figures. This one here has 3 significant figures. Test the one up, test the one down. See which one gives you the largest thing. This one has 3 significant figures. This one has 3 significant figures. But when you look at your testing, you can easily tell, hope this is, okay. Okay, so when you use this, you can easily tell that the one down is going to give you. So 45 times 12.8, 45 times 12.8, you get your answer as 576. And these are already 3 significant figures. When I test the one up, you note that the answer here you get is 396. So this one down has the largest value. So it's the one I'm going to write first. So I will say 576. When you multiply the next one, you will get 536. When you multiply the next one, you are going to get 35 times 14. You get 35 times 14, you get 490. 30 times 14.8, you get 444. 25 times 16.6, you get 415. 20 times 19.8, you get your answers 396. Now, after getting that, you go to U plus V. U plus V, we said we consider decimal place because this is addition. So when you look at the number of decimal places here, it is 1 dp. Here, it is 1 dp. Since they are the same number of decimal places, our answers will be to 1 dp. So when you come here, this is going to be 39.8. The next one is going to be 41.6. The next one is going to be, you add 44.8. The next one is going to be, now remember you maintain the decimal points 0. So you maintain to 1 dp. Here you maintain to 0 dp. The next one is going to be 53.4. The next one is going to be 45 plus 12.8, which is 57.8. And that's how your table can look like. Now, after you coming up with your table, okay. Now, after coming up with your table, make sure that your table is very neat. How many columns should we have? At least you'll find yourself having 4 columns. At least 4 columns. Do not assume, but please have those values obtained from the experiment. Okay, so let us first continue. Now, after obtaining your table of results, even indicate table of results. Now, what next is have this data analyzed. So what are you going to do? You are going to come here and have these values plotted on your graph. So I'm going to come here and I first, how do we look out for the scale to plot? Now, when these values UV from our graph, UV is going to be along our vertical axis. U plus V is going to be along our horizontal axis. What are we going to do? Identify what is your largest value. Our largest value here is 576. Our smallest value is 396. What do we do? Let me create a new slide such that I take you through how we get the scale we are going to use. So I'm going to come here. So for vertical, I'm going to call it vertical scale indicator. You get your highest value minus the lowest value divided by 10 for vertical axis. Now, your largest value for our case was 576. Our smallest value was 396. We shall divide this by 10. So what are you going to do? When you place your curve, you'll have 576 minus 396, which is 180 divided by 10. So you end up with 18. Now, after getting 18, what are you going to do? We have what we call convenient scales. So your convenient scales, we have 1, okay, a minute. You have 1, 2, 1, 2, 5. Those are the convenient scales. Then the other at worst can be 2.5. So what do? In case you want to get bigger values, you multiply by 10. So we shall have 10, we shall have 20, we shall have 50. We shall go on and have 100, 200, 500. In case the values are small, you divide by 10. So it shall have 0.1, 0.2, 0.5, 0.01, 0.02, 0.05. Now, when you look at the value we have obtained, it is 18. When you look at 18, 18 is between 10 and 20 here. So this is where you have your 18. Now, when you find that your value is lying between these two values, you always pick on the largest value among those two. So for this case, our scale is going to be this, because 20 is the largest value. So it means that the scale you are going to use on your graph, you are going to say that your 2 centimeters are going to be representing 20. That's what you are going to do for the vertical. When we go to the horizontal, I'm going to come here. Horizontal scale indicator, still you get your highest minus the lowest, divide by 8. When you look at the values that you had or that we had for our horizontal here, you note that for horizontal, our biggest value was 57.8 minus the smallest, which was 39.8. So we shall divide by 8. So when you get 57.8 minus 39.8, you end up with 18. Divide by 8. So 18 divided by 8, you get your answer as 2.25. Come here, check out, where does 2.25 lie? So 2.25 is here, between 2 and between 5. So what do? You take on this. So along your vertical, along our vertical, we are going to say 2 centimeters represent 5. So dear students, that is how we obtain our scale. That is how we obtain the scale to use on our axis. Now, when it comes to your axis, I want you now, I'm going to take you back to the table. So we have obtained that along, we have obtained that along the vertical, here we are going to use 2 centimeters to represent 20. Here, 2 centimeters are going to be representing 5. So I want you, those who have calculators, you are going to place this on your calculator. Place 0, you are placing, place as I give you instructions. So you say 0, you place an equal sign. You say 0, place an equal sign. After that, I want you to place a plus sign. So place plus. So your calculator is going to give you answer plus. Once it gives you that, put your scale here, which is 20. So place 20. Then place equals. Then continue placing equals up to when you reach a value that is very close to 396. So when you place, those who have placed, you have reached a value that is very close to 396. And which value is that? On my calculator is 380. Now, this value you have obtained is going to be your starting value. So you will start from 380, 400, 420, like that. I repeat, you listen. I have said to get which value to start with, you are going to go to your calculator, place 0 on your calculator. After that, place an equal sign. Then after that, I want you to place plus. So your calculator should be able to give you answer plus. Put your scale, which is 20. After putting 20, continue placing equals, then it's going to give you different values. Now, when you reach a value that is very close to your smallest value, that value is going to be your starting point. So your starting point for that case is going to be 380. That is what you are going to put on your vertical scale. So when I come to my graph, along my vertical scale, this is my graph. Along my vertical scale here, I'm going to start my value. I'm going to start my value here as 380. From 380, you got 400, 420, like that, up to the last value. You are going to do the same for horizontal. You say horizontal, you say 0 equals, then you say plus, your scale was 5, place 5, and then continue placing until you get a value that is very close to your smallest value along the horizontal. When you get that value, it's going to be 30. So you start from 30 and then you continue like that. Then from there, you are going to come and have your points plotted. So when you plot, you'll have your graph similar to that. I think there's a point I didn't plot well, which was 490. I think I need to look at 490 and 49. Okay. Okay. Okay, so I'm going to display the screen again. Sorry, I'm displaying the screen again. So that is what you do on your graph. That's what you do on your graph. So allow me to share my screen again. Okay, I think there is one point I didn't plot well, I think because of the multiplication. This point is supposed to be 490. So 490 is going to be somewhere. This is 480. So allow me to first make that. Okay. So 490 is somewhere. So this point is somewhere here, around here. That's where it's supposed to be. But that is how your graph is going to look like that. Now, how do you find the slope? To find the slope, you are going to read off these values. But allow me, yes, you are going to read off this value. Like I've already told you, when you are reading off the value, we look at, like I've already told you, we look at the smallest value. So vertically, when you look at the vertical, I told you here our scale we have used was 20 for vertical. So I'm going to say 20 divided by how many small boxes are here? 10. So my answer is 2. So the smallest box along the vertical is 2. So this is 0 decimal place. What does it mean? It means that the values I'm going to read along the vertical should be to 0 decimal place. Then we go to the horizontal. Horizontal, we use the scale of 5. But in between here, there are 10 boxes. So I'm going to have 0.5. So the values I'm going to read along horizontal, I'm going to read them to 1 decimal place. Now, what am I going to do? When you come here on my graph, when you check my value here for horizontal, I'm going to come down here. When you check it very well, it is here. So I'm going to say that value is 35 plus. How many boxes do I have? That those are 9 boxes. So I will say 9 times 0.5 because each box has 0.5. So you will say 9 times 0.5. So this is going to be 35 plus 4.5. So 35 plus 4.5, you get your answers 39.5. So since we have said you read it 1 decimal place, here I'm going to write 39.5, comma. Then when it comes to the vertical, the point is somewhere here. So when you check, it's going to be 380 plus. Here, roughly, sorry, it's here. So these are 5 boxes. So, but each box has 2. So that means you are going to say 380 plus 10. So 380 plus 10 gives you 390. So here we shall say this is 390. But we said you write it to 0 decimal point. Then when you come up here, you start with the horizontal. Horizontal here, you note that it is in 60. But we said horizontal values, we write them to 1 decimal point. So you say 60.0. Then when it comes to the vertical here, you note that this value here, these are about 8 boxes. So I'm going to come here and say this is 580 plus how many boxes? There are 8, but each box has 2. So you'll come and say now 580 plus 16. So 580 plus 16 gives you 596. So here I'm going to write here 596. So after that, the 2 points I have, remember you don't use your graph. You don't write this work in the graph. So what are you going to do? You are going to carry those 2 points in your workspace. So let me assume this is my workspace here. I'm going to come here and I say slope equals to the 2 points I have 60.0 and 596. Then I have the second 39.5 and 390. So what are you going to do? Here, there is no need for you to write the formula vertical scale out of horizontal scale. There is nothing. There is no need for that. So you'll come here. What you need to remember is your gradient. That this one can be, let me say this one can be your x1, y1. This one, x2, y2. You don't need to label them. So you know very well that we always get y2, which is 596, minus y1, which is 390, divided by your x2, which is 60.0, minus our 39.5. Now, when we are subtracting, we consider decimal places. So when you look at the upper digits are written to 0 decimal point. So you subtract them and have your answer here as 206. Divided by 60.0 minus 39.5. Those ones have 1 decimal point. So when you are subtracting them, the least number of decimal point is 1. So I write 20.5. So here now you are dividing. When we are dividing, you consider significant figures. So these are 3 significant figures, and also these are 3 significant figures. So the answer you get is going to be written to 3 significant figures. So you say 260 divided by 20.5. And here your answer is going to be 10.04878. But since your answer should be to 3 significant figures, I'm going to say 1, 2. Now, when you come here, this is, you can round this up to be 5 and round this. So you can write this as 10 point. Now, if you are to round off this, this is going to be 0.0. If you are to write to 3 significant what? Figures. So I write 10.0. But look at the units. Along your vertical, you were dealing with UV, which was centimeters squared. Along your horizontal, you had U plus V, which was centimeters. So this was centimeter squared divided by centimeter. So meaning that you remain with centimeters. So it means that your slope, you call the S, is going to be 10.0 centimeters. Now, after obtaining that answer, you are going to come and say your slope is this. But remember, in your procedure, you say that your slope is equal to the focal length. That's what you say. It means that the slope you have got is equal to your focal length. So I'm going to come back here, and now I say I've already obtained a slope. Then I'll say my slope is 10.0 centimeters. So it means it is equal to the focal length. Then I will come and I make a conclusion and I say the focal length of the concave mirror is 10.0 centimeters, which is in the range of 9.0 centimeter to 11.0 centimeters. What next? The hypothesis is accepted. The hypothesis is accepted. Now, after accepting the hypothesis, what next? The next thing is now to go on. The next thing is now to go on and advise accordingly. So what kind of advice are you giving? Then you can say, I advise him to use the mirror as reflectors in the vehicle headlights. So that is how you make your conclusion. But in your conclusion, please put your answer you have obtained for your quantity. The focal length of the concave mirror is this, which is in the range of this. In case you get your answer outside this range, then you say the hypothesis is not accepted, or the hypothesis is null, the hypothesis is this, and then you go on and you advise accordingly. Base your advice from what you have obtained, not from what you want, but from what you have obtained. Now, after doing so, you are going to come and write for us. Yes, must we write the hypothesis is accepted? Yes, because this is what you are testing. Remember, your hypothesis is what you are testing, whether it is true or false, whether it is valid or whether it is valid or null. Okay, I'm going to ask everyone typing in the chat to stop. People who are typing in the chat, kindly stop. Kindly stop. Yes. Okay, so you will say the please, I repeat, I am asking people who are typing in the chat to stop. Stop. Yeah. Such that you concentrate. Stop such that you concentrate. Yeah. Okay. Okay. So that is how you make your conclusion. You conclude and then you advise accordingly. Now, after that, you are going to tell us your errors in the experiment. Now, please take note. We have what called, when you are presenting your errors, I would advise that present the error and the precaution. Error and precaution. And here, please do not mix. There is a difference between a precaution and a mitigation. Don't use the words you want. Those two things are different. Those two words are different. So don't go on and say error and precaution. No, they are totally different. So here we use precautions. We use precautions. Now, how do you write your error? Now here, I want to first explain, because some of you mix the words. You say mitigation instead of, when we talk about a precaution, it means how do we take care, the caution, how do you prevent something from happening? That's what we call a precaution. A mitigation is how do you reduce the impact? How do you reduce the problem or the risk? So that is where you need to know. Now, one of the errors is what we call parallax error. In reading, now here you need to be specific. Are you parallax error? Don't just say parallax error, but you go on and say, in reading the image distance V using a meter rule. In case this parallax error, because remember, this is the value you are measuring using the meter rule. Then, what is the precaution? Place the eye perpendicular, or you can say at right angle to the mark on the meter rule. Or you can say positioning the eye vertically or normal to the point being red. Then number two, too much light in the room. Like I showed you the room where I was, and I showed you that the room where I was, there is too much light. So when you look at the room, when the light is too much, you cannot be able to get clear what? Clear result. So what precaution do you need to take? That you can say by putting curtains on the door or in the window or by closing them. Then another one, the mirror sagging in the holder. When we are talking about sagging, when you look at this kind of mirror holder I have, you notice that the mirror is moving around. It's not what? It's not firm. So in order for you to make it firm, you can add in plastic here, inside here. You can add in plastic. In case you do not have, you can improvise and say maybe, let me get some papers I put inside such that the mirror can be held firmly inside. So you can see that the mirror can move. But inside here, if your school has plastic, they can put in such that the mirror can be held firmly inside there. Other errors can be, are you seeing these cells? Sometimes they are very old. Some of you, sometimes we use very old what? Cells. So sometimes you may find that you need to get new what? Dry cells. Even sometimes some of the things you find your thing is not white, you cannot see your images very clear. Sometimes when you have these meter rules, some of your meter rules are not well calibrated. Some of the digits are not clearly seen. Some of them are very old, something like that. Some of them, even when you check this side, you find things are not clearly seen, the values. So those are some of the things you can look out for. Okay, I'm going to continue. Okay. So those are some of the things. Sometimes even aligning the mirror, the bulb in a straight line, sometimes it is very, very hard. So this is how. So when you are writing your precautions and errors, I would advise write the error and the precaution. Whatever error you write, you must give a precaution. Don't write an error when you don't know it's a precaution. If you don't know, you rather ignore it. But make sure you write that. Okay, I continue. Now, we have some common errors and precaution depending on the experiment you are working on. So, in mechanics, these are some of the common errors and precautions that you can look out for or that you can think about. How many errors? At least 3. At least 3 are good with their precautions. So in mechanics, these are some of the errors you can look out for. When it comes to electricity, these are some of the errors in electricity. And one of the errors, one of them is parallax. But here, please give where are you getting, maybe reading the current from the ammeter, reading the voltage using the voltmeter, and give that precautions. I have said I advise you to use a table. But if you can use the paragraph writing, it is also very okay. But a table is very easy for someone to score your work. Errors due to lose what? Connections. Sometimes when you are putting the connections, you find that these wires here, you are seeing my wires here. Sometimes your wires are very loose. So you find that you have connected and your thing keeps on going what? Off and on. So you make sure that when, like you are saying here, so when your wires are loose, you find that your things you are doing keep on going off and on. So make sure that when these wires here are very tight, they are not loose. Most so when you're working with things concerning what? Electricity, make sure it is very, very firm. When it comes to the meter rule, sometimes you are going to be fixing what? You are going to be fixing wires on this one, on the meter rule. Make sure that that wire is firm on this meter rule, depending on the experiment you are working on. You make sure that it is firm. I know in some schools, they have even made it better. by putting like a hint. When you look at this meter rule, they have put something to make the work easy, that thing. Instead of using cell tape to fix the wire, they have gone on to put something like this, such that it is well fixed. Okay. I've talked about poor alignment of this equipment. Sometimes some of you don't know that in order for you to align them very well, you can have your meter rule placed here. Get this, let me say this is the white spring, and this is your meter. You can make sure that these things lie along a straight line. But whenever this one is here, this one is here, you find that your equipments are not well aligned. Okay. No. Okay. Okay. Okay, so these are some of the things. Then another one that is very common is heating of the wires. Sometimes the wires we have heat up. They become very hot. Why? Sometimes you leave the switch on. Sometimes for you leave there and you go on your things. So here the precaution is that make sure that you switch off the circuit before reading, or you quickly read the values and then you open up the switch. So those are some of the errors that you are going to meet. But parallax is common in all experiments, but it depends on what you are reading. These ones can be very common when it comes to light or optics things. Allow me that we end at this point. We end here, and I'm going to wish you a good evening. But I want to respond to maybe 2 or 3 questions. Those who may have burning questions, I can respond to them. I'm seeing Chinyala, you had a question. Kindly ask.
Hello, sir.
Yes, please.
Hello.
Yes, please.
I wanted to ask that if you have plotted a graph of U plus V against UV, what is the focal length socket in determination of the slope?
I've told you when you plot U out of U plus V, it's going to be 1 out of F. I've showed you how it comes about. When you look at my screen, I've showed you that if you have 1 out of F equals to 1 out of U plus 1 out of V, this is 1 out of F into V plus U out of U plus V. Now, if you decide that you want to plot this is U plus V equals to, sorry, this is, allow me to write, okay, just a minute. Okay. This is VU. Okay. This is 1 out of F into 1 out of U plus 1 out of V. So this is 1 out of F, V plus U out of UV. Now, if you decide that you want to plot this is 1 out of F is equal to V plus U. Now, if you decide that you want to plot V plus U, this is 1 out of F and this is VU. This is going to be your Y. This is going to be your Y.
Yes.
So this is going to be 1 out of F into VU. So this side, this is going to be your M, this is going to be your X, this is going to be your Y. So when you plot V plus U against VU or UV, it means that your gradient is 1 out of F. So that means your slope, you will say slope is 1 out of F, meaning that your F will be 1 out of the slope, in case you decide to use that approach.
So, sir,
yes,
the unit of the slope, if you are
the unit of the slope. Now here, still your units, V plus U is centimeters out of centimeters squared. So you'll have 1 out of centimeters. So your units are going to be centimeters per for the slope. But your final ones for F, they will be again centimeters, because 1 out of centimeters prime is the same as centimeters.
Okay. Thank you, sir.
Okay.
So how about, I wanted you to like illustrate for us the setup of refractive index. The setup of refractive index.
Now, refractive index, you are going to have your, this is the glass block. Then you'll come here. Then you'll tell us that you have your angle of incidence here, angle of refraction. Then you have your pin 1, pin 2, then this side pin 3, pin 4, something like that. Then you label A, maybe B, C, D, something like that. Is it clear?
Yes.
Then you label that P are your pins, and then you label that this is a glass block. If you want, even you can put a white sheet of paper, something like that.
Okay.
Okay, thank you, sir. So
okay,
I'm like, our teacher said, the
Yeah.
agriculture teacher, is it
Come again?
possible? The agriculture teacher said that is it
Yes,
possible for you
come
to
again.
organize? Have said,
Yes.
hello.
Yes, go on, go on.
I've said that the agri teacher was like, is it possible for you to organize one for agriculture, the facilitation?
Okay, I will let you know. Let me plan and see whether it is very possible.
Last question, sir.
Okay, now, before we go to the last question, please take note that when you are dealing with that, please take note that for a glass block, you must have your values, the trigonometric values, written to 3 decimal places. So please take note that once you are dealing with the with the trigonometric ratios, sine, cos, and the others, you write your values to 3 decimal places. In case this was 10, 20, 30, 40, 50. So we expect here for you to say sine of 10 is, then you put here 0.174. Sine of 20 is 0.342. Sine of that, like that, is 0.500. And then you maintain the 3 decimal places. Similarly, the same thing here. Okay.
Okay,
Continue.
we have a last question here.
Yes.
For the experiment of the concave mirror,
Yes.
what if setup you put the white screen in the middle of the concave mirror and the bulb? Will it be correct?
It is okay. It will work. It will work.
Okay, now, master.
If you put the wire bolts in the middle, as long as, come again.
If you put the screen in the middle of the mirror and the light or the bulb,
you put the screen
in the middle of, in between the mirror and the bulb.
The mirror and the bulb.
Yes.
You have put the wire bolts between.
No, master, meaning putting the white.
Where are you placing the mirror?
The mirror on the right hand side. Then the bulb is opposite to the mirror, but the screen is in the middle, facing the mirror.
That one can work. However, it is a bit tricky, more so if because the light can be blocked. So it's a bit tricky, but it can work as well.
Okay, thank you, sir. Okay, now, master, on the independent variable,
Yes.
Is it correct? Like if you say the independent variable was, then you state the independent variable. Is it correct?
No, it is correct, but I would advise that just state what the independent variable is without saying it was. Just say independent variable and just write it.
Okay, thank you, sir. Then, sir,
Yes.
when you are drawing the line of best fit,
Yes.
then you say that you can represent the point with an X or a dot, then a circle around it.
Yes.
And maybe I draw mine, and maybe the line of best fit touches one of the whatever the circles, but not the exact point. Will I be penalized for that?
Ensure that if where possible, let your line of best fit at least touch 2 points you have plotted. And it balances a bit.
Like the one you've drawn, eh?
Mm.
Like the one you have drawn. Now, like count from down, it is 1, 2, 3. Then the fourth point, it's like almost touching, actually like touching the circle of the whatever of that point. But it is the line is not touching the exact point. Will I be penalized for that?
It is okay. This one is okay. It has touched at least one of the 2 points you have plotted. Yeah, but if you are perfect, at least you pass through any of the 2 points.
Okay, thank you, sir.
Thank you, sir.
Okay. Ngalama SS. Ngalama SS. Okay, I'm failing. Noah Sandy. Am I failing? Napak. Was yes, Napak?
Sir, sir, we have a question. It's just an inquiry.
Yes.
Is it possible to arrange the
When listing apparatus, are we supposed to state their uses?
Come again?
When listing apparatus and materials, are we supposed to state their uses?
Are we supposed to
indicate their uses, the uses of the apparatus and materials?
Those ones are indicated during your steps that you are going to tell us in the steps that use the meter rule is for measurement. So the objective distance U is measured using a meter rule, something like that.
Okay, sir. Thank you.
Yeah.
The next one is when you are dealing in mostly the hypothesis. I think the aim. Because at times we find that in the scenario they will tell you the reason. Like if you see the scenario for where they say that the person had damaged the shock absorber of the PK. Now from there, when you are writing the experiment, are you suppose like maybe when you write your aim that to determine the force constant of a spring in order to replace the damaged one, or that one might not be correct.
That is okay, as long as you say an investigation to determine the force constant of the spring in order It's very okay.
Okay, so,
okay. The other one, okay. See, on the side of the graph, where we were listing the
first and then
after the procedures. I thought after the procedures we were supposed to have the errors and then precautions.
It is okay where you place anywhere you place them, as long as you have them. Yeah, but I always prefer them to come at the end. Is that fine? But you can place them. You can place them. You can place them the way the report, as long as you have them there.
Okay, sir. Thank you.
So, but I want you always to look out the hint they give you. The hint they give you should guide you better. When you look at the hint, sometimes they put for you, let me say, I want to give you one of the scenarios. When you look at the hint, are you seeing the hint? Yes. So you can use the hint and present them in that format. It is very okay. But I always prefer them to come at the end of the experiment. Like I showed you the sample format for the report. So you can follow that format as long as you have them. There is no problem. Something like this. Remember, all these ones come at the end of the what? Of your experiment. Those errors, it comes when you have done them. When you have conducted what? The experiment. Not before you have conducted what? Experiment. Okay? Wasimia SS. What? Wasiam, I'm not getting you.
Good evening, sir.
Yes, good evening.
Fine. Okay, I'm like, when a learner writes, let me say,
when a learner
write two errors and give only one precaution. Is it possible?
When a learner writes,
errors and only give one precaution.
When a learner writes
two errors and then he decided not to give one precaution only.
Yeah, that learner will be penalized. So whatever thing he puts there, he must be able or he must be in position to give it a precaution. If he's not sure, he would rather leave it.
Okay.
Okay, that's
and tomorrow, which subject?
I think tomorrow. I think I need to confirm, but I know we have. I'll send you the timetable on what we shall have tomorrow.
Okay.
Okay. Okay. But maybe let me throw more light. Please and please, I want to know that your aim and purpose gives you a big weight. Independent variables, you must at least have 4 of them mentioned. When you are mentioning those things, at least make sure that independent variable 1, dependent variable 1, then controlled variable have at least 2. Yes, depending, but at least make sure you raise 4 of them. Then when you are stating your hypothesis, make sure that the statement with or without the purpose, but make sure that it is written clearly. Then make sure that you give an error and precaution. An error with a precaution clearly stated. But if you give an error without a precaution, that one is not. If you give a precaution without an error, still you are not going to be scored. So make sure at least those things are very, very clear. When it comes to the values, make sure at least you have 5 values in your table, and make sure you write your title. Those are the things that are going to give you the thing. And make sure you write a conclusion and advice related to your hypothesis, the aim, and the data you have obtained. Make sure that your conclusion, advice are related to the hypothesis, the aim, and the data. Okay, let me pick one hand. Padrob.
Yes. Hello.
Yes.
We are confused in filling the table for refractive index, whereby we are told that when we are filling sine R, we should use significant figures.
No, when we are looking at trigonometric ratio, we consider 3 decimal places. So when you are getting sine R, it should be to 3 decimal places. Is it clear?
What about sine I? Because we are told that when we are filling sine I, that's when we use DPs. But when we are filling sine R, we should use significant figures.
No, anything that deals with a trigonometric ratio, with a trigonometric function, we use 3 decimal places. Unless now when you are dividing, don't confuse that two. Hope you are not talking about division.
Yeah.
Yes.
Because those things can come when you are dividing, so don't confuse the two when you are getting sign I out of sign R.
Okay, fine.
But sign R, it is 3 decimal places. Okay.
Thank you.
Okelo?
Mara.
Yes, Okelo?
Gamba. Gamba.
We would like to ask, sir, when are we going to have facilitation for physics? Physics.
Oh, that one may come in third term. Yeah, but I'm just wondering, Okelo, can you first turn on your camera? I'm just wondering why where you are, it is still very light. What time is it where you are?
7.
Yes?
It is 7.
It is? What's the time?
Mama.
They have beautiful girls.
It is?
We are, but we are outside.
No, like it is where we are this side, it is very dark. Which district are you in? Where?
This side of Western.
Hey, you are in Iliantonde. Oh, okay. It is still very light. This side is very dark. Okay, but we shall have one in third term.
Another question.
After your mocks. Yes?
Another question.
Yes, please.
Yes, when you are writing, like you have listed variables, then you write the title variable, then down you say independent, you put the values, dependent, you put the values, controlled, you put the values without repeating the word variable since it is stated up. Is it allowed?
Oh, it is very okay. It is very okay. Say independent variable, dependent variable, controllable variable. Otherwise, when you just write independent, what are they?
Thank you, sir. No, another question, sir.
Yes.
Yes, sir. When you are dividing like figures with different significant figures, what do you do? What do you consider?
When you are dividing values with different significant figures, you consider. Okay, let me share my screen.
Yes.
So let me say you are dividing 34.1 and you are dividing it with the 12. Now this one has 3 significant figures. This one has 2 significant figures. So here you consider the small significant figure. So 3 and 2, it is 2. So you consider the value of 2. So here you'll have your answers 2.84166. But since 2 is the smallest, is what you consider. So I write my answers 2.8.
Okay, sir.
Okay.
Thank you, sir.
Okay.
Good night, sir.
Okay, likewise. Send our regards to people in Yantonde. Okay. Kibuku FS. Kibuku, you are the last.
Good evening, sir.
Yes, good evening.
For us, we want to know, instead of using risks.
Come again?
Instead of using errors and precaution, and we use risk and mitigation. Am I correct, sir?
No, you are not. Because you have created your own question. Because there are 2 things. Yes?
Our teacher told us to use risk and mitigation.
Now, when we talk about precautions, precautions refer to those actions you take before an event happens in order for you to prevent risks from happening or to prepare for it. Now, when you talk about a mitigation, is what steps can you do, or what steps have been taken to reduce the impact or the damage of that risk? That's what we call a mitigation. Then,
now,
when you talk about risk, a risk, when we talk about a risk, is like a potential of experiencing a negative consequence or a loss or something like that. An error is an action that has already gone wrong. A risk is the potential of something to go wrong. Are you getting the difference? Have you got a difference? That an error in practical, an error we are looking at what has gone wrong. That's what we are looking for. What has gone wrong and what action can be taken, or what have you done? Then a risk is the potential for something to go wrong in the future. So if you are looking at risks and mitigations, those ones you write them even before you do the experiment. Is that clear? Have you got the difference?
I've got, sir.
Yes, even when you look at the hints, you look at your exam paper, when they give you a hint, they have told you they want error and precaution. Error is what has gone wrong. Why haven't you gotten that result, the actual result? That may be reading the meter rule, maybe this and the other. Okay, hope it is fine.
That you, sir.
Okay. Then Julio something. Ngalama SS and Padrop.
Thank you.
Yes.
Good evening, sir.
Yes, good evening.
Yeah, I would just like to inquire because I know you are a facilitator and you can do almost in all the subjects. Like since we are in new curriculum, they say it is a field, it is car field.
Come again?
I'm saying new curriculum, they say you can do transfer from one field to another.
From one?
There was one from one field to another. I'm just trying to describe new curriculum. So like you can integrate the knowledges in those different subjects. The one day they gave us practice on chemistry. Then I tried to use the technique of physics, which is saying when you are drawing the line of best fit, if all your points are not aligned on that very straight line, you should at least make sure that it should at least touch what is touching and balances what it is leaving. Like it can touch 3 and leave other 2, one on the other side and one the other side. Then that teacher said it is not correct. That for chemistry, for them they need the straight line, which is taking like almost point. So I was confused because in physics, when you are drawing line of best fit, you can balance. You can at least attach 2 and balance the other remaining on either side. They should at least balance equal. So I don't know what you can tell me about that one.
Now one is that much as we are integrating application or like knowledge, what applies at your home may not apply in other person's home. So there are some things that may apply in physics and they may not apply everywhere.
Okay.
So you need now to know the dynamics But the principles, one of the principles that can across all are the plotting skills, but not everything that applies this side also applies the other side.
Okay, that point is noted.
Yeah.
Okay, thank you.
Okay. All right. So allow me that we end here our session. Let's meet tomorrow. Oh, tomorrow I think we have ICT. Tomorrow we have ICT. But why don't I ask these people of Leantonde to pray for us? People of Leantonde, unmute and you pray for us.
Let us pray.
This is Chevanka.
Let us guys.
Okay, we are ready.
Our kind and loving Father, we thank you for this time. We thank you for the lesson we have studied, the physics practical. We thank you for all schools that were connected on this internet, Father. May you protect us. Give us your knowledge and understanding as we are going to start our mock examinations on Monday. Protect us, even bless that facilitator who has helped us. We have prayed through believing and trusting in Jesus' name.
Amen.
Okay. Bye. Bye. Okay. Okay.
Okay,
Bye.
nice time.
Bye. Okay, nice time. Bye.
Just